Hi everyone, today in this video we'll be discussing the second module of DBMS and in this module we have the following topics and I'll be telling you which topics are the important and how to remember the queries and everything in this. And if you watch this video till the end, easily you can score more than 80% marks, so don't miss any of these concepts. Watch till the end, and if you have any doubt you can bring me on Instagram here. Okay, so without wasting more time, let's get started. Before starting, please do like and subscribe, it helps me make more videos like this. So the first topic is relational model concepts. Okay, so we'll understand what is relational model concepts. Okay, so relational model represents the database as a collection of relations. Okay, relation means what? Something related. Okay, two things are there, it is related in some manner, like father and son. Father and son, there is the relation between them. So a collection of such relations is called as a relational model. Okay, we'll be seeing what is a relational model. Each relation resembles a table values. Okay, all the relations we store in a table. Okay, and table consists of rows and columns, and each of these cells will have a value. Now in the terminology of DBMS, we will be representing the rows as tuple, column as attribute, and the table as relation. Okay, now the values inserted in each cell can be chosen from a domain of values. Domain of values means what? A group of values, a domain of fruits, or a domain of vegetables, domain of phone numbers. So from there we'll choose those values and we'll be storing in these cells. Okay, now domains, attributes, tuples, and relations. A domain is a set of atomic values. Okay, indivisible values means that values cannot be divided into two. Apple, there is one apple only. Okay, apple cannot be divided into AP and PL. Okay, it is indivisible, it is a single thing, like that. Okay, some of the example of the domains are like USS phone number data set, local phone number data set, social security number data set, names data set. Anything which consists of group of values is called as a domain. Okay, and what is a relational schema? Relational schema gives us the information about which are the column names. Okay, column names is also called as the attributes. What are the attributes present in the particular table or a relation? That is called as a relation schema. Okay, and what is degree or arity of the relation? It is the number of attributes. How many attributes are there? That is the degree. Okay, listen again. How many attributes are there? That is what? That is the degree. Okay, in the exam they can ask you the question for the definition of arity. Next, in the table, if there exists no value, we'll be storing it as null. So in this example, you can see tuples of a relation student. Like there is a student 1, student 2, student 3 till student 5, and they all have the values of the SSN, home phone number, address, and office phone, age, and GPA. As you can observe, there is in office phone there is null present here because they are students, and students do not have office phones, right? So they will be having null here. But there are some students who is having office phone also. So how we can consider this is these are the students who are working individuals, right? So they have office phone as well. So whichever does not have office phone will be storing it with null. Okay, now what are the characteristics of relation? There are 4 characteristics. The first one is ordering of tuples in a relation. Ordering is not required. Okay, ordering means in which order it should be stored. That is irrelevant because I want the information which is present here. These are the facts present here. Okay, so ordering is irrelevant. Next, ordering of values within a tuple is also irrelevant. Whether I give name first or address first, then I give the SSN, or if I give the name after that and home phone number at the end, I will give address, I will take at the last. Whatever I do, in whichever order I give the values, I am giving the values, and that's all I am concerned about. Okay, so this does not matter, the values within the ordering of the values within the tuple. Next is values and null in the tuple. As I explained, null means if the value is not applicable, we will be storing there as null. And interpretation of the meaning of relation means relation is giving us the value of a tuple as an assertion. Assertion means a fact. Okay, whatever the particular row is there, we will get facts about that particular row, right? Whether the student, where the student is from, what the student is studying, what is the phone number of student, what is the email of student, what is the sex of student, all those things. Okay, we will be getting those information. So these are the 4 characteristics of a relation. Next, relational model notation. How do we denote a relational model? So the attributes are denoted by A1 till AN, and the uppercase letter denotes the relation names, and smaller case denotes the relation states, and TUVR denotes the tuples, whichever the tuples are there. Okay, and whichever the relation is there, they will be having some attributes. And if you want to access that particular attribute, for example, if I want to access student name, so I'll be writing student dot name. Dot operator is used to access that particular attribute from the table. Okay, and tuples are also present. We can do the operations on tuple, which we'll be discussing in the upcoming topics. Okay, now relational model constraints and relational database schema. First, relational model constraint means there are some constraints or restrictions. We cannot insert whatever we want. There are some restrictions what you can insert, what is acceptable, what is not acceptable. So basically there are 3 types of constraints. The first one is implicit constraints. These are inherent in the data model. Okay, it means the data, how it is defined, according to that it is present, that restriction, that is inherent or implicit. Next is the explicit, which means we define what restriction should be there. Third is the semantic or the application based. For example, student age cannot be greater than 150 in a student database. Okay, that is a application based because humans don't usually live for 150 years. Okay, so That's the constraint. Next, a few more constraints are there, like domain constraint. Domain constraint means if there is a value insertion for the fruits and I insert a brinjal there, so it is a domain constraint because brinjal does not belong to a fruit domain. Next is key constraint and constraint on null values. Okay, key constraint means the main key, like for example in student database the main key can be the student ID because it will be unique. This student ID cannot be duplicate, means two students cannot have the same roll number, and it cannot be null also. None of the student has a null ID. Okay, that is an invalid student then. So these two are the constraints here. Okay, and super key is the main key which we use, like for example student ID, and key is just a general attribute like SSN. Every attribute or the column is called as a key. Okay, and candidate key is the key which is eligible to become the super key. Okay, for example phone number and email ID can also become the candidate key. But why? Because this will be unique. Two people cannot have the same phone number or same email ID. So whichever is unique and it cannot have null values, that is a candidate key. Okay, and null values are not permitted in super key. Listen again, null values are not permitted in super key because super key is used to identify the rows. Okay, if you put null value, how can we identify that row? We cannot identify that row, right? So it should not be there. Next is relational database and relational database schemas. Okay, relational database has constraints. Okay, and whenever there is a constraint and the database does not obey that constraint, it is an invalid state. Okay, so schema for employee database is given here. So this is an employee table with the attributes here. This is a department table, this is the department location, and so on. And all these tables form a database. Listen again, all these tables form a database. Got it? And what are the underlying things, right? These are the key values. Okay, super key values. Based on these super key values, we will be identifying the whole tuple. Okay, for example, if I ask you select an employee whose SSN is 734, so 734 SSN will be selected. Okay, so it will be unique. Okay, so this is an example of a schema. This is how schema looks like. They will be showing you the table name as well as the attribute names. Next is the entity integrity, referential integrity, and foreign keys. Okay, entity integrity means what? Integrity constraint states that no primary key can be null. That's it. Referential integrity means what? See, suppose that two tables are referring to a single value. For example, here we have D number, department number. Okay, this department number is referred by this table also, D number, and here also we'll be referring this one, right? D number. So this is a foreign key because one key is connecting two tables. Okay, that is called as a foreign key. And whenever we have foreign key, we have a referential integrity because we cannot delete this table unless and until we have deleted this D number. Why? Because if we delete this table and D number is present, where is this pointing to? Is this pointing to air? No, it does not point to air. Okay, so it should be present. There should be a link. Okay, that's why if the link is broken, that is a referential integrity constraint error. Okay, and foreign key, just now I mentioned a same key in two tables. Okay, listen again, same key in two tables is called as a foreign key. Now foreign key acts as a meeting link between two keys of different tables. Now suppose that an employee works in the department 5, and in that department 5 I have another thing. Where is the department 5 located at? So department 5 is located at London. So employee works in department 5 and department 5 is located in the London. So there is a link between these two via a attribute called as D number. Okay, so this is called as a foreign key, and all the types of foreign keys are given here, like for example ESS and P number. So employee is working on some project. So which project the employee is working on? What is the employee's ESSN? Both are the foreign keys. Okay, this is how foreign keys work. Now there can be some constraints in that. First is semantic constraint. Semantic means in a university database, student age cannot be negative or above 150. Okay, that is a common sense integrity constraint. Functional dependency constraint. That means employee ID if we have, we can get the employee name. Okay, so that is a constraint in which by knowing one thing we can derive the other thing. State constraint means in a bank database, customers balance cannot be negative at any time. That is a state constraint. The state should be positive. Transition constraint means if you are changing from one state to another state, it should be not decreasing or making any inconsistencies. For example, employee salary cannot decrease from one month to the next. Okay, that is a transition constraint. Next is update transaction and dealing with constraint violations. Now three operations we'll discuss. Insert operation. Insert means there is a database and you are inserting any row. Okay, that is called as an insert operation. Now there can be four types of constraints. Okay, very important. First one is domain constraint. Domain can be violated if you take the value from some other domain which is not appropriate for the data type. Key constraint can be violated if key value in the new tuple already exists. If you are inserting a student who's already existing, there can be a key constraint. Entity integrity constraint means if any primary key can be put as as null, then it will be an integrity constraint. Referential integrity means if you are violating the referential integrity, if any foreign key does not exist in any other table, but you're inserting that foreign key, referring to that that it exists but it does not exist actually, so it will be a referential integrity constraints. Two examples are here. We are inserting this record, but it is a having a null value at a primary key. Okay, so what happens? It will throw an entity integrity constraint. Next one is this employee already exists, so if you try to insert again this employee, it will throw a key constraint. Okay. Next one we'll be discussing of the delete operation. Okay, delete means what? There is a row here. When we'll be deleting this row means, suppose student 5, I want to delete student 5, I'll be deleting from the table. That is called as a delete operation. But here also some things can happen. See, this is acceptable. If you want to delete this one, it will be deleted then. But this cannot be deleted. Why? Because this SSN has a integrity constraint or the referential integrity constraint with the other table. Some value of this table is referred to in another table. If you delete this one, what will the other table have? It will have nothing. So that is an invalid state. Okay, it should have something. So you cannot delete this one unless the integrity is removed, and then you can delete it. Okay, that is the delete operation and its integrity constraints. Next is the update operation. Okay, update means you are updating some value. Basically, if you want to update the employee tuple with SSN of this to this one, whatever this is the salary. Okay, salary suppose it was 25,000. You want to update it to 28,000. Whose salary you want to update? The person with SSN. This one you want to update the salary here. So you can give this command and it will be accepted. So here also it will be accepted. Okay, so this is the update operation. Next is the transaction concept. Okay, basically what transaction concept says is that whenever you perform a transaction, the database should be in the valid states. Okay, it should not go into an invalid state. Like for example, it started from here, it did not reach the destination, half data is here, half data is not here. This kind of thing should be avoided. Okay, that is a transaction concept. Okay, it should be an atomic unit, means whatever is the true is there, that should be true only. Okay, if change is made as false, it should be made as false. It should not be in between, half true half false. Okay, like that things is not acceptable. Whenever you're doing some operation, that should be ensured. And the whichever the state the finally the database is in, all the things should be valid there, and it should not have any constraints. Okay, so this is the transaction concept. Next is the relational algebra. Okay, now we have discussed what is the relation. A table is there and everything is there, right? We are performing the operations on it, that is called as relational algebra. Okay, so there are two types of operations that can be performed in relational algebra. First one is the mathematical set theory operations like union, intersection, set difference, Cartesian, and cross product. We'll be discussing each of these with example in the upcoming topics. Stay tuned. And here we have another type of operations called as select, project, join. And in this, once what we will be doing is the whole table will be there. We'll be selecting a part of the table based on some conditions. Okay, so this is for this we'll be using the select, project, and join operations. Now let's discuss the first, which is unary relational operations. Unary means there is no two variables required, only one operator is required. That is called as a unary. Okay, select and project, and we'll be just requiring one table for this one. Okay, now select means what? If there is a table here, for example student table, I want to select all the students who have an even roll number, means 2, 4, 6, 8, 9, 10. Sorry, 2, 4, 6, 8, 10, 12, 14, 16, and so on. Okay, I have to just select those ones. Okay, so I'll be specifying a condition and I'll be selecting. For example, if I want to just select the employee with the department number 4, so we'll be selecting here as this is the sign. Okay, symbol for the selecting a tuple. The tuples have to select whichever has the department number as 4, and here the salary whoever is greater than 30,000 have to select those employees. Okay, so there is a condition defined here, and this denotes the tuple which is getting selected, means that rows will be selected which will be having either department number 4, employee working on, and salary is equal to greater than 30,000. So those will be selected. Okay, that is used for the selection. Select user select selects the rows. Okay, I'll repeat, select selects the rows which satisfy the following conditions. Now project means that you will be selecting the columns. Okay, there will be a table, right? In that table, if I want to just select, for example this is the table, and I just want to select the L name, F name, and salary. Okay, so what I will be doing is I'll be giving a command like this, pi I will be writing, and I will be writing F name and L name and salary, and I'll be giving the table name employee. So when I give this command, what will happen? I'll be getting this answer here. Okay, because here what I have selected is F name, L name, and salary. Okay, and any other condition also can apply. Salary should be greater than this or that, so it will be selecting accordingly. Okay, so basically that is how you do the project operation. And tuple operation selection means select all the tuples with the D number 5. Okay, if I give D number 5 and I give employee here, in this case what will be selected? First row will be selected, the whole row, and third row will be selected, the whole row. Okay, so there will be 2 rows in the final result. Next is a sequence of operation and rename operations. It's obvious that when we perform an operation, there should be sequence. If you don't follow sequence, some rubbish will come. Okay, so you don't want rubbish, right? So you'll be giving the sequence. Okay, what sequence you have to follow? First, select the department 5 employees. Whosoever is working on department 5, select those, and after that select the first name, last name and salary of those employees. That will be in the result. Okay, this is the sequence. First you cannot do this and then do this, because if you try to do this first, dep5 emps is undefined. Okay, this will be a rubbish value for the computer because it's not defined. So that's why define it first. Okay, then use it. Fine. Then the next one is the rename operation. Rename means whatever the operation you are performing, that can be renamed to a particular value. Else again you have to write the same thing in the final equation. Instead of that, we are renaming it to temp, and we are using temp here. Okay. Next, the relational algebra operations from the set theory. Okay, so here we'll be understanding three operations: union, intersection, and minus operation. Okay, so basically, what is union? Union is the combination of two things. Okay, so if this values is given, four values are here and two values are here. If I do the union, there will be six values, but here, as you can see, it is just having five values. Why? Because one of the values is same. Okay, 3 3 3 4 4 5 5 5 5. This is same value, so it is just written once. So combination of these two and just writing the common values once, that is called as union operation. Okay, and intersection means whichever is common in between these two. Can you tell me which is common in between these two? Yes, only this is common. So if you do the intersection, this will be the result. Only the 3 3 3 4 4 5 5 5 will be the result. If you do the subtraction, okay, subtraction or the minus operation. Okay, in minus operation, what happens? From this table, okay, listen to me carefully. From this table, remove all the rows of this table. Okay, from this table, remove all the rows of this table. In this table, we have the third row and the eighth row. Eighth row is not here, so we are not concerned about it. Third row is here, it should be removed from here. So when I do the minus operation between result 1 and result 2, I'll be getting the final result as 1 2 3, and here 6 6 6 and 4 5 3. Okay, got the point. The differences between union, intersection, and set difference. Okay. Next, this is the same example given here, and examples are given the table with respect to the table. So if we just go through it quickly, okay, see what is the thing. First, they have given the table student and instructor. Okay, then what they have given, student union instructor. So this is student, this is instructor. If you do the union operation, whichever is the values present here and here, that all will be added up, and the common values will be written just once. Okay, that is the means what is this? This is the union. Okay, and intersection means the common values between these two are written here. As you can see, Susan and Ramesh, and he is here and here also, right? Susan and Ramesh, right? So Susan and Ramesh will be intersected, and it will be written here. Next is minus operation. Minus means student minus instructor means what? From student, remove all the instructors. From student, if you remove the instructors, we'll be removing Susan and Ramesh from here, and this will be the result. And the next one is instructor minus student. From the instructor, remove all students. From the instructor, how many students are there? Susan and Ramesh. So if you remove, it will be John, Ricardo, and Francis. Okay, so John, Ricardo, and Francis will be the final result here. Next is the Cartesian product or the cross product. Okay, let's take an example and understand. Here, this is a table A with student ID and name. Okay, so one is Alice and two is Bob. And here is the course ID. 101 is maths and 102 is science. Now, if you do the cross product, what will happen is each row will be assigned with each course ID and course name. So, 1 Alice 101 maths, 1 Alice 102 science. Next, 2 Bob 101 maths, 2 Bob 102 science. Okay, so each of these row is getting assigned with these two, this row is getting assigned with these two. That is called as a Cartesian product. Okay, next is the binary relation operation. Here two tables will be required. That is why it is called as binary. In the previous one, only one was required, where we are either selecting the rows or the columns. Okay, here two are required. So there are two operations in that: join and division. Okay, let's understand what is join. Okay, with example you can understand. Now see, there are two tables. Again, the student and the courses table is here, and these values are given here. Okay, but there is, as you can observe, there is a student ID here also and here also it is. So when we do the join operation, what will happen? This student ID and the name will be joined with the corresponding course and the course name. For example, one is the student ID of the Alice, and Alice student ID is corresponding to 101 and maths. So the final row will be 1 Alice 101 maths. Second one is Bob, and second one is related to 102 and science. So if you write it together, it will become 2 Bob 102 and science. This is called as join operation, joining the two tables. Okay. Equijoin is also a similar condition, but we'll be having an equality symbol. Means only join those students which will be having the course as equal to the student ID. Okay. Natural join again is the same join which I just discussed. Okay. Now, a complete set of relational algebra operations. We discussed many operations, but the five main important ones are selecting the rows, selecting the columns, union, minus, and Cartesian product. Intersection is a redundant one because you can use these symbols to calculate the intersection as well. Okay, so this is the complete set of relational algebra operations. If they ask in exam, you have to write this one. Okay. Next is the division operation. Let's understand with an example. Okay, this is a table given for the student courses, and this is the courses given here. Now, if you divide, what happens? Division means math and science. Which student is studying both maths and science? That is my question. Which student is studying both maths and science? This is R. This is S. R is related to student courses. S is related to courses required. So if I do R divided by S, my final answer will include those students who are studying all the courses which is present here, maths and science. So Alice is studying maths, Alice is studying science. I have selected Alice. Next, Bob is studying maths, Bob is studying science. I have selected Bob. Next, Charlie is studying maths, Charlie is not studying science. So my final answer will include Alice and Bob. Okay. Next, what is operation is the notation for a query tree. Okay, query tree is nothing but we'll be representing the algebraic operation in the form of a tree. For example, if I want to select the project and the department, suppose that there is a project P and there is a department D. I want to select all those projects which are being executed in the department D. So I'll be combining these both. Okay, firstly I'll take the project location as Stafford and department as the D number. Wherever the project's department number is equal to the department's department number, that will be selected. Then I will be selecting those employees who are working on that project and department. So it will be coming here. So finally we'll be having all the values of the employees who are working on a particular project in a particular department. Okay, this type of representation is called as a notation for query trees, and this is the summarization of whatever we have learned. You can go through. This is a very important like a diagram, kind of diagram you can understand, and here it is used for the reference. Okay, you can for the revision purpose you can use this table. Okay, next is the additional relational operations. Till now we discussed many operations like the selection operation, join, and the other ones also we have discussed. So those operations are there. Apart from that, there is additional operations also. So the first one is generalized projection. Okay, generalized projection means, what was projection? Projection was selection of the attributes, right? If this is a table, you're selecting the particular attribute values. Okay, that is called as a projection. But here we have the generalized projection. That means if I want to just select those values whose net salary is salary minus deducted, whose bonus is 2000 into years of service, and tax is 0.25 into salary. So basically we are doing some mathematical operations on the values, and then we are selecting those values. So in that case we will be calling it as a generalized selection. Okay, generalized projection. Okay, next is the aggregate functions and grouping. Aggregate functions means what? We have all the tables. For example, consider this table. Okay, we have laptop, phone, tablet, and we have the prices and the quantities given. Now aggregate means what? I can find out the sum of all the quantity. How many total quantities are there? 15 plus 8, that is 23, right? 23 quantities there. Or what is the total price? That is equal to sum. Like that we can calculate the sum. Average, we can calculate what was the average price of these three. Add these three divided by 3. Okay, so in SQL we can just give average and to calculate as which attributes average you want, price, quantity, like that. Okay, next is the maximum. Which one is the maximum among these? 60,000. And which one is the minimum? 20,000. And what is the count? Count means how many values are there. There are three values: laptop, phone, and tablet. Okay, so those are the things we can find out from a table using aggregate functions. Okay, so 5 aggregate functions are there. The first one is the count, second is the sum, which I just discussed, average, minimum, and maximum. And group by also we can do. For example, if I want to group by sales, okay, sales means how many laptop have been sold, how many phone have been sold, and how many tablet have been sold. So based on that I can group it according to the product, and that will be the grouping. Okay, so this is a summary, you can go through it. Okay, these are the relational algebra operation. This is syntax you need to write. Okay, third one is the recursive closure operation. Okay, this also I can understand using example. Suppose employee A reports to manager B, and manager B reports to another manager C, and manager C reports to manager D. So basically A reports to B, C, and D, and B reports to C and D, and C reports to D. So there are 6 recursive closure operations, because indirectly who is reporting to whom, that also we can find out. Okay, so indirectly A is reporting to B, A is reporting to C, A is reporting to D, and B is reporting to C, B is reporting to D, and C is reporting to D. Okay, so this is the final result which we will get if you do the recursive closure operation, and this is the formula, can go through it. Okay, next is the outer join or and outer union operation. Okay, join we discussed, joining the two tables. Now let's understand what is outer join. Okay, so this is the table which is a student table and courses table is given. Okay, now we have 1 2 3 here and 1 2 4 here. As you can observe, this third student does not have corresponding ID in the course. Okay, so if you do the left outer join, what happens? Left values will be kept. Okay, listen again. Left values will be kept. Left values means 1, 2, 3 will be kept. So Alice, Bob, and Carol will be selected. Alice, Bob, and Carol will be selected. And after that, in the place of Alice, we have maths, and Bob we have science. Why? Because Alice was 1 and 1 is related to maths. Bob was 2 and 2 is related to science. Carol was 3, but 3 is not there anywhere. So for Carol, we'll be putting it as null wherever we don't have. That is the left outer join, because left we selected S. Okay, so left values will be kept here. None of the null will be there. If you select the right values, that will be having the courses, but English is not corresponding to any of the student, because there is no student with the roll number 4. So it will be having a null here. If you keep it in the right, it is called as a right outer join. Full outer join means both will be selecting here. One null will be there, here one null will be there. Okay, now next is the outer union. Union means what? You'll be combining these two. Okay, for example, 1, 2 and 3 is there. So 1, 2 and 3 will be taken. Okay, so see here, 1 will be the Alice, and the age of Alice is null. Why? Because here age is not given for the student ID1. Student ID1 there is no age, so it will be null here. Okay, and the third one, the third, there is no student here, but there is a age for that student, right? So it is, there is student not given here, but some students age is given. So we don't know which student it is, but their age is 21. Like that, it is called as a union, outer union. Okay, so got the difference between the outer join and outer union. Very good. Now next is the queries in the relational algebra. Okay, we'll discuss 3 queries. Okay, so in the exam they can ask you retrieve the name and address. Okay, what you have to retrieve? Name and address of all employees who work for the research department. Okay, so basically what we'll do, we'll give research department here, and you have to select all the rows where the department name is research and select from the table department. Then select all the employees which will be having those department numbers. Okay, which will be the research department, because they have asked the name of all the employees. Then also we'll be selecting the address of all the employees. Okay, next is the, for every project location located in Stafford, list the project number, controlling department, and the department manager's last name and address and date of birth. So all those things which they have given, project number, department name, last name, address, and birth date, we'll be keeping it at the end. Okay, but before that we need to calculate, we need to find out whichever the projects are in Stafford. So in Stafford projection, we'll be storing the rows which have the P location as Stafford. Then we'll be finding out the departments by using join operation, whichever the projects have the same department as the department number. And after that, we'll be taking that value and taking the employees who are working on that projects. And then finally, we'll be selecting that rows which have the particular attributes given in the question with the tuple values. Okay, so this is how you do the for the query 2. The query 3 is related to find the names of employees who work on all the projects controlled by the department number 5. First is, in department number 5, how many projects are there? Next, in that project, select the P number. Okay, because we need the project number. After you've got the project number, find out which employees are working on that project number from the works on table. So we have the employees who are working on that. Now based on the employees, we have to divide it by 5 in department 5. As I explained, division, what it does, the employees who are working on all the department projects, that one will be selected if you do the division operation. So this will have all the employees who are working on the department 5 projects. Now we have to find out the names, right? They have given. So name means L name and F name of what, of this thing. Okay, and X employee. Okay, so we'll be getting in the result all the employees who are working on the projects of all the projects of department 5. Okay, the last topic is mapping conceptual design to logical design. This is a short question. Okay, every time it has asked in the exam. Relational mapping. Okay, now this is the company schema. So yeah, let's quickly go through it. This is an employee, and this is the attributes of the employee, like the F name, middle name, and the L name, and the address and the birth date. Okay, and employee is supervised by the supervisor. Okay, and supervisor is also an employee, so it is getting mapped to itself back. Okay, and n employees are supervised by one supervisor. Okay, and employee works for a department, and department manages an employee. Okay, so department will have its own attributes, and department controls the projects. Okay, and projects are worked on upon by the employees, and employee has some dependents. Okay, dependents, the dependent name will be given like the family members. Okay, so this is a company schema. Now to map to the steps for the mapping, what it means is this diagram has to be converted to a table. Okay, basically, so how do we make a schema out of the diagram? So first is convert all the strong entity sets into relation. Strong entity means what? The strong entity is this one, employee, whichever is in a rectangle. Okay, only single rectangle. So 3 strong employees are strong tables are there: employee, department, and project. This is a weak one because it is a double rectangle. Okay, double rectangle is weak one. So whichever is having all the strong entities, take those attributes and put it here. Okay, and department also will do the same, and project also will do the same. The SS means What is this? This is the primary key will be underlined. Okay. Next is mapping of weak entity types. In the example which I have taken above, the weak entity type was a dependent, and dependent depends upon the SSN of the employee. Okay. Based on SSN, there is a connection made. So if you see at the top, there is a connection made via the SSN. Okay. There is a SSN which is connected to the employee. Employee's main attribute is SSN, and via SSN we can identify who it is dependent upon. Okay. So we'll be adding another value SSN, and that will be pointed to the employee, so that there is a connection formed. Okay, that is the second thing. Foreign key will be there from the dependent to the employee. Next is mapping 1:1 relationships. 1:1 means what? One employee can have one salary only, it cannot have 10 salaries. Okay, so like that. 1:1 means one employee is managed by one department. 100 departments cannot manage one employee, like that. It is stupidity. So one employee is managed by one department, and that is 1:1 relationship. Okay, and one employee has one dependent, like that. Okay, so this is the 1:1 relationship. Whichever has 1:1 relationship, you have to map it. Okay, what do you mean? Mapping means what? We'll be getting a connection between these two. Okay, so employee is here and department is here. One employee is handled by one department, so we'll be adding a value here for the SSN, which SSN is working for the department. Okay, like that. Then we'll be mapping 1:n relationships. Like for example, in one department there can be n number of employees. In one department there can be n number of projects. For one employee there can be n number of dependents sometimes as well. Okay, so one department, n employees. So how can we map 1:n? Okay, so we'll be writing it all here, and this one is here, the SSN is here, and the employee is here, and the D number will be added here, so that will be pointing to whichever department it is working on. Okay, means the employee is working on. Next we'll be mapping M:n relationships. Okay, means M employees can work on n projects. Okay, means 5 employees can work on 3 projects, like that. Okay, so SSN will be there for the employee connection, and P number will be there for the project connection. So which employee is working for which project, that will be there in one single table. That is called as a mapping M:1 relationship types. Then we'll be mapping multi-valued attributes. Like location is multi-valued attribute. There can be many locations where the projects are presented, right? That's also called as composite attribute. And the name can be F name, M name, and L name. Okay, these are the not atomic values. Okay, and the multi-valued attribute means that uh, one attribute will be having multiple values, like London, New York, and so on. Okay, and this one, the name is not a multi-valued attribute because it is divided into 3 parts, but a person cannot have multiple names. Got the point? Okay, so whichever has the multi-valued attribute, what we'll be doing is the location is present here, right? So department location will be creating, and location will be present here, and department will be present here. Okay, so there will be a mapping made between the department and the location. Okay, last one is the mapping n array attributes. Okay, n array means supply will be here, and supplier does the supply, and from the supply the project gets taken into consideration, and from the supply the part is made. Okay, so supply is related to supplier, project, and part. So what we will be doing is supplier will be making here with the main key value as the S name, and the project with the main value is project name, and part there's the part number main thing, and supply will be having the S name, project name, part number, and quantity. So all of these are interconnected. Okay, the supply is interconnected with these 3 things. So these 3 things main will be here. Okay, and the quantity is associated with this. So supply is associated with the project name, part number, and the supplier's S name. Okay, and it itself has a quantity, so the quantity will be given here. So this whole thing can be represented in this form. Okay, this is what all what you have to do in the ER mapping. Okay, 7 steps are there. Explained with this example whatever I told, it should be sufficient for the full marks. Okay, that's all for this video. If you found this video helpful, please do like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you next.